Hi everyone, good evening. So I hope you watched all the last three lives and videos also are there. Right. And tell me one thing. Am I audible to all? Tell me one thing. I'm looking at the chat. Tell me, am I audible to all? I'm looking at the chat. Am I audible to all? Am I audible to all? Okay. Okay, now we can continue. You know that how this series is going on, right? So our agenda was, we were planning something like after this series, after this series, right? You should be at least what you can crack, right? All coding questions, all coding questions in any interview, right? Including what? Including product based and service based, right? Any kind of, any kind of. So that's what we were planning, right? That's what we were planning. And for that purpose, what we are doing is that, hi everyone. So for that purpose, what we were doing is that we were planning a sequence of series, right? So we were planning a sequence of series that was math, then we will solve array. You remember, right? You remember already. You know that already, right? Then strings, then two pointer, right? Then sliding window. So a lot of important question and so on, right? A lot of important question on all of these topics and many more like linked list, has set, has not, a lot of things, right? So we'll continue. Today in the same series of math, we already have solved three questions. Today we'll solve question number 4, which already has been asked in multiple companies, especially in Google, Microsoft, Amazon, Bloomberg. You have seen on the title, on the thumbnail itself, right? And the question is super important. So let me show you what is the question is. I'll go back to the LeetCode, and here is a one question. And don't think that this is super easy, huh? It's a medium one, and trust me, there are a lot of things which you'll learn in this question itself. So now here, look at this. The success rate of this problem is 36.3%, which means very less, right? Which means that if we will read the problem normally, we won't be able to directly solve it. There is something hidden. There is something hidden which we need to figure out in the problem itself while solving it, right? So something is hidden that we need to figure it out. So now read the problem once and tell me what you are understanding. Implement a power x to power n, which calculates x raised to the power of n. So which means that we need to write a program. We need to write a program. I'll go back to the whiteboard again. We need to write a program which, which what will do is that will calculate power. Calculate power. Right. Calculate power. So this is what something we need to do. For example, there is a math function you already know, right? Math dot power. And what if I'm passing here 5 comma 2? So what will happen? I'll get an answer like 5 to the power 2, which will become 25. Yes or no? Which will become 25. So that's what we need to implement, but we cannot use directly it, right? Let's see, let's submit this problem with this method as well, or this applicable or not. What will happen if I will submit this code? What will happen if I will submit this code in the coding contest or in a question where it has been asked in companies in interview? So that time will it work? Will it work? Math dot power. If I write here that x to power n, if I write here directly, so will this solution applicable? Right. Now this is the question. This is the question, right? So will this solution will be applicable? So that we want to check, right? So again, all the test case has been passed. If I'll submit this, so we will be able to submit this as well, right? But you cannot, if the problem itself was this, like you need to write a solution which will get you the power of something, right? So you cannot directly use any function. That is not a right way. Okay, interviewer will not accept this solution. So what will be the exact solution? We have to understand the logic behind it, like how we can implement this, right? How we can implement the existing math function, math.power function, how we can implement, right? So one way can be like, let's say if you will ask me that I need to calculate 5 to the power 2. What I can do is that I can multiply 5 by itself how many times? 2 times the power of time, right? So we can have a for loop that will calculate a result and that will run till the power n, right? And every time in result we'll keep multiplying this number itself, right? We'll keep multiplying, multiply is equals to 5. So will this work? Will this work? Let's try. Let's try. Will this work? Okay, because I know it won't work. After a certain time, what will happen? You'll see that the value of n is too large. You can see here, which will be minus to the power 31 to the power 31 minus 1, right? So that range is very large. What will happen? You'll see the time limit exceeded in the solution itself. So that shouldn't be a right approach. That shouldn't be a right approach. And again, these problems are super important. If you are following this series with me, trust me, as of now, maybe you are thinking like, sir, I'm getting the solution, whatever you're telling me, but I'm not able to make logic by myself. It will come with time. Once you follow the series, it will come with time. Okay, it will come with time. Now, okay, so now again, what will be the another logic? If I cannot directly calculate like this, if I cannot calculate directly like this, like I cannot multiply all the value till n because of the value range of n, which is very large. That will, will be beyond the time complexity. The time will take a lot. So we'll see a problem which is, time limit exceeded. So now what is the solution? What is the solution? How we can reduce the number of times of multiplication? There is a one way. There is a one way and very nice way. Okay, I'll tell you. There is a one way. Think about a situation. Let's say we have to the power 5. Can I write it to the to multiply to the power 4? Can I write it? Just listen me very carefully. Huh? You'll understand. And trust me, the solution of this problem is really hard to understand for normal people. Normal people means who are beginners in DSA. For them. Okay, so now again, if I further want to calculate this, can I see a pattern here? What if I do is that I can write this like this. You know how I can write this by multiplying 2 by 2 and I can make the power of 2. Again, this will same because to the power 4 or to the power, 2 the power 2. That is also to the power 4. Yes or no? Which means that if we multiply base value by itself, we can reduce the power by half. Now, you know how many times of multiplication has been saved? If we multiply the base by itself, we can reduce the power by half. That will optimize the solution, right? That will optimize the solution. The value of n will be reduced. Making sense to you? Yes or no? Right. So now again, which means that now we can write this like here 2 multiplied by 4 the power 2. Again, if this power is even, we can make it half. Yes or no? So again, what we can do is that we can multiply by 4 by itself, which means 4 multiplied by 4 and power 1. Yes or no? So this becomes 2 multiplied by 16 and at the end we'll get 32. Yes or no? So now you see that if I wanted to calculate it by multiplying, I have to perform 5 steps. 2 multiply by 2 multiply by 2 multiply by 2 multiply, right? 5 steps to calculate the multiplication of it. Yes or no? But with this logic, we can reduce the number of steps. Means solution can be optimized further. Yes or no? Right? That is a way. That is a way. There are chance to optimize the solution. So now what I can do is, I have figured out a logic. Like when the power is odd. When the power is what? Odd. That time we can't do anything. We have to take that number, we need to multiply and result. And we can reduce power by 1. But if we have power as even, we can multiply base by itself and we can reduce the power by half. Yes or no? that will calculate that will optimize a lot of steps. Now the problem we could face is that time limit exceed will not face as of now, right? So now here I'm taking another example. I'm taking another example. I hope that will make more sense to you. For example, let's say I have to the power 8. Okay, to the power 8. It's a even number. N is even, the power is even, yes or no? The power 8 is even. So now if the power is even, what we can do, we can multiply by itself, means 2 multiply by 2, and we can reduce the power by half. So 8 by 2 means 4. Yes or no? 8 by 2 means 4. Now again in the next step what we can do, again this becomes 4. So now if we want to multiply a base by itself, we have to reduce power by half. So this will become 2, right? Correct correct Gundu, correct, right? Correct, Ria. So now again we'll get what, this is 16. So again if we want the multiplication, what we have to do is that, what we have to do, we have to make it 16 multiplied by 16. Yes or no? 16 multiplied by 16 in power 1, right? And whatever is the multiplication of it, we'll get the output. Maybe I guess to the power 56, like 256, maybe we'll multiply it, we'll get it, right? So we'll get the value. So anyhow, we could have to perform around 8 multiplications here. And now we can see we are doing this in 3 itself, right? You're getting the number of steps are, reducing substantially. Yes or no? Right? That is a way, that is a form to find a solution. So because if we could multiply directly, that will take a lot of time. We will get a problem which is time limit exceed. But for the even values, what we can do, if there is a even power, we can multiply base itself and power will reduce by half. So every time the input value will be reduced by half, right? So that this means that time complexity will be reduced a lot. Yes or no? So now let's see how we can implement this. Now how we can implement this in the code itself. Okay, we'll go to the code window. We'll go to the code window and keep interacting. Huh? I want to know it's engaging or not. It's not be a monologue. Huh? I want some interacting students here. Right? Okay. Okay. So now here, let's we continue. But again, read the value of n means the power can be negative and positive as well. Right? There are two chances. So what we have to do is that for negative power, we know that what we do for the negative values. So let's suppose there is a to the power minus 5, which means 1 upon to the power 5, right? So whenever there is a power is in minus, what we do is that we write that number just in the base of 1 in the denominator, right? So now again what we'll do is that for, let's say, taking the output will be in double. Look at this returning value. So for output I can make a variable which is double. So I'll make it name as result, and starting, because no matter what is the power of any number, at least value will come 1, because to the power 0 is also what, 1, right? So double, I'm making this. Now again, what if the number is negative, right? What if number is negative? So now here, if number is negative, we have to keep a record. Yes or no? So what I can do is that I can make a duplicate of it. And again, there is a one problem also I will show you, but not now. Okay, I'll show you, but not now. So let's say I'm assuming number, or I'll say power. Power sounds good to me. Power is equals to n. Okay, because we know that n was the power. So I'm copying this because by saving the original number, I don't want to change it. Okay, I don't want to. Abhay present. Okay. Okay, so now here what I'll do is that if n is less than 0, which means if power is less than 0, which means power is negative. Yes or no? Power is negative, and from our logic we cannot calculate the power negative values. Yes or no? So now what we can do is that we can make that power positive by doing what? By doing multiplying by 1. Yes or no? So now here I can write n multiply by -1. Yes or no? I can do this. So now what will happen? That the power will become positive. And if power become positive, which means number will come in denominator of 1. Yes or no? number will come in the denominator of 1. So now here, which means the value of x will become 1 upon x. Yes or no? If power is negative, which means number will come in denominator, right? So that is the logic. Again, we'll keep multiplying number until unless power becomes what? Power becomes 0, right? Power becomes 0. So now we will keep running this loop when power is greater than 0, right? Now here what we'll see is that if number was, if the power was what? Even. That time what we were doing? Tell me what we were doing? We were multiplying by base itself and we were reducing the power by half. That was the logic we figured out. Yes or no? So now if the power is even, if the power is even, if the power is even, so what we can do is that we can multiply by number, we can multiply number by itself. Yes or no? And power will be reduced by half. Power will be reduced by half. Yes or no? That was the logic we figured out, right? Now here, if it's not even, which means power is odd. When the power was odd, we were directly multiplying that number into the result. So result is equals to result multiply by what? X, and power will be reduced by 1 because one time we have multiplied particular number. So now the power will be reduced by 1, right? I hope that is making sense to everyone, right? Here you can use power minus as well. So now here is a simple logic, right? We have figured out. Now at the end we can return the result, but that will cause an error. Once it will cause an error, let me show you how. For if you will run this, I guess it will work fine. If you will run this, it will work fine. But when you will submit this, okay, but when you will submit this, see what happens. For the very long values, when the n is very greater, very lower in the negative numbers, that time we are getting a problem. It's not working properly, right? Why? Because integer, this value is the the out of the range of the integer's value, the lower value of the integer. So now what we can do is that where we are doing the power integer, we can convert that number to long, and here we can perform a type conversion for storing the maximum, larger and minimum values, right? Like the minimum value of integer as well. So now here I'll do long. Okay, so now here if I do this, I'll submit this again. And see, is this working? Okay, see, now this is working 100% beats, right? 0 millisecond, which means one of the optimized solution that we could perform here, right? So this is the logic. I guess everybody got it, how we have created this logic. But I also want to dry run this, how this whole logic is working. I also want to dry run this. Okay, so now here I'll go to the whiteboard and I'll tell you the exact logic, how we have created this logic and how this is working, right? So again, I'll go here, I'll tell you that how this whole logic is working. Okay, I'll take my whiteboard again. I'll tell you how this whole logic is working, right? So what was happening is that, we were getting n as input, right? Double was x was a base value, right? Yeah, I'm gonna explain again. So again, x was a double value, which was a base value, and again n was a power, right? So now here the logic was here the x, which was double, right? Which was double, and it was the base value. The base value. It was what? It was base value. Now again, we were getting the power, right? Which was n. It was integer value n. So this was what? This was power. This was power. And for example, we want to calculate to the power 8. So how we can do? Or I'll what I can do is I'll make an odd number here. Because for even number, it will be in the same thing, but I'll make an odd number here. I'll make a to the power, let's say 8, whatever it is. Okay. So I'll make this. Now what will happen? Again, 8 is again an even number. That was previously. I'll make a 9. Okay, I'll make it 9. So now our logic was like, if number is negative, if this power is negative, like as of now it's a positive, yes or no? As of now this is positive. But if the number is negative, So that time we were checking like if n is less than 0, so which means that we have to convert that power to a positive number, right? Okay, I'll tell you, sir, in even case how you are storing them in the values of the result. Explain it. I'm explaining again same. Okay, so now what will happen? We are making that n is positive. Yes or no? So for that purpose, you remember we had created one variable type of long to store the very lowest value of integer. So that was like I have created a variable power, and in power we are storing n. You remember? So now here we were updating the power with the positive value. So power we had written long, and here we were multiplying it like what? We were writing here n multiply by minus 1. So that will become positive. Yes or no? And if the power was negative, which means the number will be 1 upon x. Yes or no? Right? Because anyhow, if I'm writing to the power minus 1, which means 1 upon 2, 2 will be in denominator. Yes or no? So that was the logic. That was the logic. So now here, this was, I guess, till here it's clear to everybody, right? Now again, if we take a while loop here for multiplying, we were writing like we'll keep executing this until unless power becomes less than 0, right? So now here for even number, how we were working it, we had written if if power is even, if power is even. So that time what we were doing is that we were multiplying x by itself, means we were doubling the base value and we were reducing the power, right? So power will be power of half, right? So that was the logic. I'll explain you. I'll write on this. I'm writing this code again here to explain on the board. Okay. So now again in the else part, what we were doing is I'll remove this. In the else part, what we were doing is in the else part, that if the number is odd, so what we were doing is that in the result we were multiplying what? We were multiplying by x itself, and again we were reducing the power by 1, right? Power minus minus, reducing the power. And the end, what we were doing is that after this loop, we were returning, we were returning, we were returning, we were returning our output, right? Which was the result. So like how this working? How is this working? Again, let's put the value. Okay, put the value. We were assuming that we have a value which is to the power 9. I want to reduce the thickness of this, or else I want to change the color. It's fine. To the power 9, right? To the power 9. So again, to the power 9, which means the value of x is, 2, and the value of n is 9. Yes or no? Here the value of power will be 9. Yes or no? So now here this will not work because it's a positive number. So now we'll come to the while loop. Is 9 greater than 0? Is 9 greater than 0? Tell me. Yes, it is greater, which means this condition is true. We'll check like, is this even? No, this is not even. Listen this whole diagram carefully. Only then you get the solution. Okay. So now check. Is this 9 is even? No, this is not even, which means this will not work. This will work. Right. So how this will work? We'll get a result here. Result previously was 1.0, which means 1.0 multiplied by x, and x is 2. This becomes 2.0. Yes or no? Now the power previously was 9. Now the value of power will become 8, which means now this is even. Now this is even. This while loop will again check, is 8 greater than 0? Yes, it is. Now check, is power even? 8 modulus 2 is equals to 0? Yes or no? Yeah, it is. It is 0, right? So what will happen? What will happen? You'll see x is equals to x multiplied by x, which means 2 multiplied by 2, which means we are writing to the power 8 equals to 2 multiplied by 2, which means 4, and we are reducing the power by half. Can we do this? Tell me, can we do this? 2 the power 8 means 4 the power 4. Yes or no? If we are multiplying by base, we can reduce the power by half. We can reduce the power by half, right? So now what will happen? We will see that this becomes 4 the power 4. Again the power is even. Again the power is even. So what will happen? What will happen? Because 4 is greater than 0 and power is even, will come again to here. Again will multiply by base itself. So 4 multiplied by 4, and the power will be half of it. Right? The power will be half of it. Right? Got it? Yeah. So now this time what we'll get? We'll get 16 multiplied by 16. Yes or no? And power will be half of it. which means power is 1. Now, if the power is 1, we'll see is 1 greater than 0. Yes, it is greater than 0. So is 1 even? No, it's not even. We'll go to the else part, which means 1 is odd. Now, here we had 16 multiplied 16 into 256. I guess this is the multiplication, right? So now here what will happen? You'll come to the result, and result previously was, what was the result? Result was 2.0. Yes or no? So now the value of result will be here again 2.0 multiplied by 256. Yes or no? And power will be reduced by 1, which was 1 becomes 0. So now this will be 512. 500. I'm not able to write. Why? This will become 512. Yes or no? 0.0. Now the power will become 0. Why? Because power minus minus, power was 1. So 1 minus 1 becomes 0. Yes or no? So now the power is 0. Power is what? Power is 0. So now is 0 greater than 0? No. This while loop will be terminated. At the end we will return the result. At the end we will return the result. Got it? Got it, everybody? Tell me. You got the logic? How we are writing this? There are other logics too. You can figure out by yourself, right? And we'll see you in the next live, right? And where we can discuss the doubts as well. And anyhow, I want that this is, trust me, super important series for everybody who want to be a software engineer. Every question which I'm covering here has planned in a sequence, like if somebody is coming from 1 to n, 1 to 150, he will have a very super coding skills and a problem solving. You want to be stuck in the interview, right? So that's what I'm planning it. And also I'm planning one more thing. I want to plan a project series, some cool project series, like some kind of animations you can add, some kind of front end, back end, that sharing some data, right? And the complete, from basic project to intermediate to advanced project. I'm planning a project series. Let me know how you people are, how you will want this series, you want or not. Let me know in comment box as well. Okay, whenever you're watching this video, even the live or the normally recorded video, but let me know in chat, are you excited? Actually you need the project series or not, where we can have super amazing animation effects as well, super, the projects which are really stand out on the resume. If you want these projects for free, I can create a series for the project as well. Okay, here I'm seeing some yes, but also, okay, do not forget to add in the comment as well, because live comment will be hidden after this. So in the normal video also add the comment. Okay, I'll create a project series, super amazing project, which definitely will help you to select in any company. Right, I'm planning the series. Okay, sure, I'll create that one, because I want to be covering a lot of theory there, but I'll tell you the important theory only, like the complete Monstack projects, the React project, the HTML, CSS, JS projects, right? The GSAP, how we can include GSAP with React JS, how we can create some cool animations. So I'll create that kind of series for you guys. Okay. Okay. Thank you, everybody. And again, if you want some amazing content from me, keep sharing these lives, because management will only allow me to do this kind of life when we are producing some kind of output. I'm actually helping the people, right? Only then this is possible. So keep sharing these lives with your friends as well, by which they can also have a chance to learn something amazing for free. Okay. Okay, bye bye. All the best. And again, try to solve this problem by yourself as well. Whenever you solve a problem, take a pen and copy and try to dry run like me, I've done here. Okay, then you'll get everything. Okay, bye bye. Bye bye, everybody. Bye bye.